This question is asking us to find derivative of this function at point 2, 3. In order to find the derivative of this function, we need to use implicit differentiation, because I know that y would be very difficult to isolate from the rest of the function. When you're using implicit differentiation, what you really need to remember is that when you're differentiating x, you have to write dx over dx next to it, and when you're differentiating y, you have to write dy over dx next to it. This is because you're differentiating dx in terms of dx and dy in terms of dx. Dx over dx is the same thing, so you're gonna just write 1 because it cancels out. Another function that you have to use is the product rule. Product rule states that if x and y are multiplying and you're finding differentiate of that would be x, differentiate of x, y plus differentiate of yx. Supplying two of these things, we'll find derivative of the function. So derivative of this function is 2xy squared, and you won't have to write dx over dx because that's 1. And then product rule says plus x squared 2y dy over dx equal 1 plus 2. And to rewrite it, it's 2xy squared plus x squared 2y dy over dx equal 3. And now we're going to isolate dy over dx. So we can subtract 2xy squared from 3. And then we can divide the term on the right side by x squared 2y. And now we have dy over dx, and we have to find it at a point 2, 3. So x value is equal to 2 and y value is equal to 3. Plugging that in, we'll have 3 minus 2 multiplied by 2, and 3 squared is 9, divided by 4 multiplied by 6, because 2 multiplied by 3 is 6. And that would be equal to 3 minus 36 over 24, which is 33 over 24. You can simplify it if you want. I'm just going to leave it to that. Let's try to do another problem using implicit differentiation. The function we're going to use is x squared y cubed equal xy plus 1. We're going to find it at point 2, we're using implicit differentiation and product rule. So product rule will give us 2xy cubed plus x squared 3y squared dy over dx equal y plus x dy over dx. Derivative of y is equal to 1, so we don't need to write anything else but dy over dx. And derivative of 1 is equal to 0, so we do not need to write that as well. And now what we have to do is we have to isolate dy over dx. We're going to first bring everything that has dy over dx multiplying with it to one side. And then factor out dy over dx. And then divide the term on the left hand with the term on the right hand and leave dy over dx on one side. We have a function for dy over dx. So in order to find the derivative at one certain point, we're going to plug the points 2, 1 in the function. So it's 2 multiplied by 2 multiplied by 1 minus 1. 2 minus 4, 2 squared is 4, and then just 3. And that is the dy over dx. So if we try to simplify it a bit, we'll have 4 minus 1 and 2 minus 12. Simplifying it a bit will give us 3 over negative 10.